Hello, my name is Bailey McCurry, and this is my Lab 10 report over centripetal acceleration. For this lab, we needed the rubber stopper attached to one end of the string, and then a glass rod with the string threaded through, and then on the other end, we had a paper clip to measure the distance, and then our hanging weight was the washers with a paper clip on the end to make sure that they don't fly off. So for exercise 1, we were studying how the varying length of the radius of the rotating mass will affect the period. So we were timing how long the period was for that rotating mass. The relationship between the radius and the velocity of the rotating mass. As the radius decreases, the velocity increases. So the velocity is going to speed up as your radius gets shorter. And then what is the relationship between the velocity of a rotating object and the centripetal force exerted on it? The centripetal force is proportional to the square of the velocity, and that is found through the formula of F equals m times v squared over r. So from that formula you can see that the centripetal force is directly proportional to the square of the velocity. Okay, and then for the second and third exercises, we were studying how mass affected the centripetal force. For exercise 2, we changed the hanging mass, and for exercise 3, we changed the rotating mass. So we just changed the number of washers on the end for exercise 2. And then for exercise 3, we added washers in with the stopper on the other end. So what is the relationship between the mass of the rotating object and its velocity? As the mass increases, more force is needed to maintain that motion. So as your mass increases, your force is going to need to increase. And then when graphing the values of velocity versus velocity squared, did you notice any differences? Since the centripetal force velocity is directly proportional to the velocity squared, the graph was somewhat linear. And that pretty much concludes all of the exercises that we had to do. Thank you.